For students with dietary restrictions and allergies at the University of Chicago, the simple process of going to the dining hall for a meal can be incredibly stressful. It can be difficult to figure out how to comply with dietary restrictions, with students forced to read through every ingredient to ensure the foods they are avoiding are not present. This takes significant time and effort and is particularly inconvenient when the dining hall is crowded with long lines. Labels on dishes, such as vegan or vegetarian, are present, but as many students with food restrictions have learned, they are often inaccurate and misleading. For instance, dishes containing cheese, egg, and even chicken broth have been incorrectly marked vegan. UChicago's dining company, Bon Appetit, does have an online menu that students can refer to. To attempt to find suitable food, however, the student must still look through the entire menu, find a station that seems to have potential, open up the expanded view for that station, and then read through the individual ingredients for each dish. You can filter, but only by a few of the major dietary restrictions. Even these aren't perfect. Sides from other stations may meet dietary restrictions, even if the main entree does not, but these dishes won't show up. And of course, they still rely on the very labels that users do not trust to begin with. For a user with a specific allergy or other dietary restriction, these filters are completely useless. To solve the problems facing students with dietary restrictions and allergies in the dining hall, we brainstormed and then proposed 3 initial designs. The basis of each is a personal dietary profile that allows users to select from an extensive list of dietary restrictions and allergies, as well as enter other specific allergens by name. These preferences are saved and used as the lens through which the user views all other dietary information in the app. The first design operates at the dish level. Individuals can scan a food and, leveraging machine learning and computer vision, the app identifies the food, accesses specifics on the ingredients through the menu, and presents a verdict to the user as to whether they can eat the dish. The second design operates at the level of a station in the dining hall, such as kosher or herbivore. The user scans a QR code displayed at the station, and a page is pulled up in the app that lists which dishes at the station the user can eat. The third design operates at the dining hall level. In the dining hall or ahead of time, the user can select the day, time, and dining hall and get a high-level view of which stations contain suitable food. We conducted initial user testing with a medium fidelity prototype that combined the filter and QR code prototypes, the 2 most popular and technically feasible designs. Participants tested the profile setup process, as well as attempting to find food based on specific restrictions using the QR code and filter models. We also got in-class feedback on the profile setup and filtering components. After user testing, we decided to fully implement the filter prototype based on feedback from our target users that the QR code model did not add value and was more inconvenient compared to seeing the dishes ahead of time. Target users also expressed a desire for more personalization and feedback that their restrictions were being used to build system trust. They also wished to know more immediately why they could not eat a dish by listing the specific ingredients or potential cross-contaminant that went against their restrictions. The first time the user opens the app, they will create an account to set up their dietary profile. To set up their profile, they choose from a list of dietary restrictions and can also enter any number of custom allergens. This profile is then saved and will be used to customize the app. Now, the user can use the app anywhere at any time to see what options are available that fit their dietary restrictions at dining halls across campus. After logging in, the user can select the date, the dining hall, and the meal they wish to view. They are then shown a list of the stations serving that meal, color-coded by compatibility of the dishes at that station. A green station is serving all compatible dishes. A yellow station is serving some compatible dishes. A red station has no compatible options. Clicking on a station shows the user the dishes being served at that station. The user can view more details about a dish, including why it is not compatible with their restrictions. The incompatible ingredients are highlighted in the ingredients lists for easy recognition. Compatible dishes are clearly marked in green. The user can still view the ingredients list if they wish, to verify compatibility and to build trust in the system. Now, when the user goes to the dining hall, they are equipped with knowledge about what dishes from what stations they can safely consume. They don't have to read ingredient lists or roam around looking for compatible options. Their visit to the dining hall becomes less stressful, more efficient, and more enjoyable. They can plan their day and meals ahead of time, and there's no more worry about or anxiety about what they'll be able to eat.